Okay, my algebra kids, this is section 3.6. It is the quadratic formula, and I really like to teach this in class to you today, but, I'm gone, so you just gotta make it work, I guess. The quadratic formula is kind of a nasty, ugly formula, but, whether you like it or not, you probably will have this formula memorized by the time you get done with this section, or at least done with this chapter. I have a song that I usually play for you, and I'll play that tomorrow when I'm back. If I'm back by tomorrow, I'll play that song for you, and it'll kind of help you remember the quadratic formula a little bit. So let's talk about what this thing does, though. So we're still talking about quadratic functions, which are y equals x squared, which are still like parabolas, and we're still trying to find these places where he crosses, okay? So in section 3.4, we talked about factoring, okay? And the four methods of factoring were used to find those places where he crosses, right? We could find that stuff. And that was the GCF method, the simple trinomial, complex trinomial, and difference of squares. Those four methods help me find those places where he crosses, okay? And in section 3.5 then, we learned that like sometimes factoring doesn't work, so we do completing the square. Complete the square, and that allows that allows us to find those places where he crosses when factoring doesn't work. So we do that when this fails. Okay, now we are going to learn the quadratic formula, which a lot of people like better than completing the square. In fact, my like trig and calc kids, they prefer it because they're able to remember how to find or do the quadratic formula better than they can complete the square, which is fine, whatever. But the quadratic formula is something that will always work. When other methods fail, use this. Okay, when other methods fail, use this method, okay? And it is negative b plus and minus the square root of b squared minus 4ac all over 2a, okay? So example 1, we're going to be doing the quadratic formula, and we're going to be finding where those zeros or x-intercepts are, okay? So the first thing that we want to do is get everything to one side. So we want to set it equal to 0. Completing the square was the only method that we wanted to get the number on one side and the x's on the other. The quadratic formula, we want to move everything to one side. So I'm going to subtract this 11 and have it go over there. So I have equals 0 on this side, okay? X squared, I cannot add these two together because one has an x and one doesn't. So I just write him like this. And then all we do is identify what a, b, and c are based upon our function. Okay, so a is the number that's in front of this, which since there's no number, we assume that it is 1. B is negative 10. C is negative 11. Okay, and then we just plop into our formula. So I'm going to kind of zoom out here so we can see this guy. We have x equals, okay, we start with negative b, and b is negative 10. So we have negative 10 plus minus, that's this part right here. Okay, the square root of b squared is negative 10 squared minus 4 times a times c. I'm just plugging stuff in, all over 2 times a, okay? And we do this, and then we simplify, and then we're done, okay? So let's get some simplification done. Minus and negative 10 is going to be plus 10, so this is 10, plus and minus, and then let's simplify some stuff inside of here first, okay? So negative 10 squared, if we just do that, negative 10 times negative 10, that's going to be 100, okay? Negative 4 times 1 times negative 11, that's going to be positive 44. Like two negatives are going to make a positive. So we have 100 plus 44, and that's the square root of 100 plus 44, okay, which is like the square root of 144. And the square root of 144 actually comes out nicely. It is 12 all over 2. Okay, so what I have going on, it's 2 because it's 2 times 1. 2 times 1 is 2. Okay, there we go. So now I actually have two answers. I have 10 plus 12 divided by 2, and I have 10 minus 12 divided by 2. That's what the plus and minus does right here. Okay, so 10 plus 12 is 22 divided by 2. That's going to be 11. And 10 minus 12 is negative 2 divided by 2, which is negative 1, okay? So we used the quadratic formula, and we are finding those two places where he crosses are at negative 1 and positive, wherever 11's at over here. Those are the two places where my parabola is going to cross, okay? So using the quadratic formula, we found that, all right? Let's go to this next one, and let's identify he is ready to go. He's equal to 0, and we're going to start with what A, B, and C are. A, B, C. All right, A is that 1 again, B is positive 8, and C is positive 16, okay? Now we're going to start with our formula. I'm going to try to zoom out enough so that you guys can see this. We have x equals negative B will be negative 8 plus and minus the square root of B squared is 8 squared minus 4 times A times C all over 2 times A, which is 1. Okay, we're just plopping those numbers in there. All right, and now we do our simplifying. Okay, so negative 8 stays as negative 8, plus and minus the square root, and then let's simplify some of this stuff inside of here. So 8 squared is 64. Negative 4 times 1 times 16 is negative 64. Okay, so we have 64 minus 64, which is just going to be 0. That's kind of odd. All over 2 times 1, which is 2. Okay, well, the square root of 0 is just 0. It's like saying, what do you take times itself to get 0? The square root of 0 is 0. So we have negative 8 plus and minus, or excuse me, negative 8 plus 0 over 2, and then we have negative 8 minus 0 over 2, okay? And you're probably thinking, like, what's going on here? This is kind of weird, okay? Negative 8 plus 0 divided by 2 is just negative 8 divided by 2, which is negative 4. And negative 8 minus 0 divided by 2 is still negative 8 divided by 2, which is still negative 4. So we get two answers, but they're the same answer. Okay, they're the same answer because we were adding 0 to each time. Adding and subtracting 0 is going to make that be the same answer. So that was kind of odd. And what that's going to look like is on our coordinate plane here, we're at negative 4, and he's only touching at that one spot, which means that his vertex is hitting that spot. And we've kind of talked about that before. So he's not coming down and crossing twice like this one was. We only have one solution here, right, where it has negative 4 is the only place. And that was, you know, they kind of gave us a little hint about that in example 2, where we have one rational root. This one we had two rational roots, okay? In example 3, this says irrational. I don't like to call them irrational roots. I like to call them no solutions or no roots. Okay, so we're going to have something happen here where we don't have any roots or we don't have any zeros here, okay? So we'll kind of do this the same way, same thing. A, B, C, going through here, we do the same formula. So we figure out what A is, figure out what B is, figure out what C is. Here we go. We've got 2 is A, 6 is B, negative 7 is C. Also, I want to talk to you about like the x's that go with this. Make sure that you're not including those x's in your ABC, right? Don't like make it 2x squared and 6x. It's just the numbers that go in front, not the x's as well, okay? So same thing again, we do negative b, which is negative 6, plus and minus the square root of b squared, which is 6 squared minus 4 times a times c. All over. Oh wait, this is not going to have 2. Maybe I have a typo here. I think this one's going to have a root. Erase that. Erase that. These are irrational roots. Oh yes. Okay, so we're going to have a solution here. It's just going to be an ugly solution. Still a solution, but an ugly solution. Okay. All right. So here we go. Let's simplify some stuff. We've got negative 6. That stays, but then let's figure out what this is. 6 squared is 36. Negative 4 times 2 times negative 7. 4 times 2 is 8. 8 times 7 is 56, and it's going to be a positive 56 because we have two negatives. And so then we've got 36 plus 56, which is 92. All over 2 times 2 is 4, okay? Now, the square root of 92 does not come out nicely. So what we're going to do is we're going to just leave our answer like, well, come on. We're just going to leave our answer like that because 92 does not come out nicely. Like up above, we had the square root of 144, which did come out nicely. This one does not, so we're just going to leave our answer. Now, what I'm going to tell you is that this still means that we have two answers. We have -6 plus the square root of 92 over 4, and we have -6 minus the square root of 92 over 4. Okay, and so I'm going to show you what those two answers look like if I type them into my calculator. I have -6 plus the square root of 92 and divide that by 4. Oh, come on. Oh, come on. Let's do this. -6 plus the square root of 92 all over 4. Okay, and that ends up being 0.90 abouts. Okay, so it's that decimal 0.90, and then I'm going to go back up and I'm going to change that to a minus now instead. And whoa, come on, clear on. What did you just do? My calculator. Minus the square root of 92 all over 4, and that answer is -3.9, something like that. Okay, so we still have two places where he crosses. He's crossing at, here's 1 and -1, 2, 3, 4. He's still crossing here and about there. Okay, but he's going to end up being really ugly decimal places where he crosses. That's kind of how that works. Okay, all right, last one of this type of example is same thing again. We want to make sure we get the 10 moved over so that we have them set equal to 0. And we have x squared minus 6x plus 10. And we are going to identify what a, b, and c are. A, b, c. Okay. A is 1, b is -6, and c is positive 10. And we're going to do our stuff. So negative b would be -6 plus and minus the square root of b squared minus 4ac all over 2a. Okay? All right, and then we just simplify. So this is going to change to positive 6 plus and minus the square root of -6 squared is positive 36. Whenever you have a negative inside of here, it's always going to turn into a positive because you're squaring it, okay? So we have 36, and then -4 times 1 times 10 is a -40, okay? Now, 36 minus 40 is going to be a -4 all over 2. So here's the deal. We ended up with a negative inside of a square root. And you might remember that from like section 3.3 that we did. That's going to turn out to be an I. So we have 6 plus and minus. The square root of 4 just makes 2. But if we have a negative there, it's plus and minus 2i all over 2. Okay, now one more thing that I will say, if you want to leave your answer like that, that's fine, but notice that these will reduce, and it's kind of like I call it kind of like a butterfly reduce. When you are reducing, both of these top numbers have to reduce in order to be able to reduce anything. So I have to cross out this 6 and this 2 here in order for that to work. So this would become 3 plus and minus 1i. If I reduce the 6 by 2, it's 3. If I reduce this 2 by 2, it's 1, and then this would become a 1, okay? So like putting that 1 on the bottom, whenever you're dividing by 1, you don't necessarily have to have that number there. So it's 3 plus and minus 1i. So what that means is that we have zeros that are imaginary. So he's not crossing the x-axis. We don't have any zeros. He's not crossing the x-axis, okay? All right, so that was the quadratic formula. That was the full-blown quadratic formula 100%. Then they're going to talk to us something about what's called the discriminant, okay? Now, the discriminant is a piece, just a piece of the quadratic formula, and is just the stuff that's underneath of the square root. The discriminant is just b squared minus 4ac. B squared minus 4ac, okay? So let me give you a scenario for the discriminant, and I'll kind of show you how this works. Okay, b squared minus 4ac. Up above here, like on, let's say, example 1, if I look at my stuff, my quadratic formula, the discriminant, or the thing that I got underneath of the square root, was 144, okay? So like in example 1, my discriminant, I'm going to call it D, equals 144, okay? And when I had my discriminant as 144, I really had two answers. They were -1 and +11, okay? So I had two solutions when my discriminant was 144, let's say, okay? But then let's go on down to, like, let's say example 2, where here I ended up getting a discriminant, whatever was underneath of the equal sign. It was like 64 minus 64, which came out to be 0. In that case, my discriminant was 0. And we only ended up with, if we remember back from up here, we ended up with -4 and -4, which were the same answer. We only had one solution there. And the reason why was because when we were adding 0 and subtracting 0, we end up with the same answer, right? So when your discriminant is 0, we only end up with one solution, okay? And then let's look. I'm going to run out of room here. Here we go. Let's look at like example 4. So this was example 2. Example 2 was an illustration of that. If we look at like example 4, we see that our discriminant was -4. It was whatever was underneath of that square root, so -4. And there, we did get a solution. It was like 3 plus and minus 1i, but that still means there's no 0. So it's kind of like getting no solutions, I guess. You get an expression, but it doesn't mean anything. It's like no solutions. So we get no solutions when that happens. Okay, so here's the rule. If the stuff that you get underneath of the square root, which is called the discriminant, if that number is a positive number, like positive 144, you're going to get two solutions. If that number is 0, you're only going to get one solution because you're adding 0 and subtracting 0. And if your number is a negative number, like this one, negative, you're going to get no solutions because you cannot take the square root of a negative number. It's imaginary, right? So that's kind of how that works, that discriminant works, okay? So if we bump over to the back side, this is what it's illustrating right here. The stuff that we just got into talking about is kind of illustrated in this chart, but I feel like mine is a little bit maybe clearer to understand and less bogged down with stuff. So let's go ahead and let's try to use that that information to do this backside stuff here. So example 5 says find the value of the discriminant. That's the first thing that they want us to do. Okay, remember that the discriminant is just the stuff underneath of the square root. So it's just b squared minus 4ac. That's all we have to calculate to find the discriminant. And then they want us to find the number of solutions that we have. Okay, so b squared minus 4ac, we're still going to do the same thing here. I'm going to label out the a, b, and c, but rather than doing the entire quadratic formula, we're just going to do this part of it. Okay, so a is 7, b is -11, c is 5. All right, b squared is -11 squared minus 4 times a times c. Okay, and then we're just going to calculate this. So -11 squared is 121. It's positive because it'll always be positive after you square it, right? -4 times 7 times 5. I'm going to do this in a weird order. -4 times 5 is -20. Now if I take that times 7, that's -140. Okay, so that's kind of how that works. And 120 minus 140 is a -19, I believe. So that's the value of the discriminant. Now we said if that value is negative, it's like taking, like in the quadratic formula, we would have a bunch of junk and a bunch of junk, and we would end up with -19 on the inside, right, of the square root. And you can't take the square root of a negative number. So that would mean that there is no solutions. So what's happening is this parabola is not crossing. It's just like hovering above that x-axis. That's kind of how that works, okay? Same thing with part B. Let's find the discriminant. So they want, let's do A, B, C here. So we've got A is 1, B is 22, C is 121. Okay, and we would just want to calculate that b squared minus 4ac, just the stuff that's underneath. Okay, so b squared is going to be 22 squared minus 4 times a times c. And I don't have a calculator, I don't know these. 22 times 22 is 484, that's 22 squared, minus 4 times 1 is 4 times 121. I bet that's the same thing, 484. So we end up getting 0 there, okay? and that's the value of the discriminant. So we found the discriminant is 0, okay, just like we had up here. The discriminant was negative 19, okay? But what that tells us is that when we had this quadratic formula, we would end up with that stuff plus and minus the square root of 0 all over this stuff. And when we're adding and subtracting 0, we're going to end up with the same answer, which means we only have one solution, and that's what they want, okay? So here we answered both parts of the question. We said that the discriminant was some number, and then the number of solutions that we have. So negative 19 was no solutions, 0 was one solution, and that's kind of how that works, okay? So maybe refer back to this when you're doing your homework assignment. That's kind of what is the important part there, okay? This stuff right here, I'm not going to go through each one of these, but this is just like the summary of graphing, factoring, the square root property, completing square quadratic formula. These are just all methods that we've used in the last couple sections to find the zeros. But this is saying that always can you use the completing the square and quadratic formula versus it only sometimes works to factor and it only sometimes works to graph. Sometimes it's just way too ugly to do that. So there's how that works. On your homework assignment, let's just have you do the odd numbers. And so 1, 3, 5, 7, 9, 11, and then 25, we'll have you attempt 25 also. But let's look through here, and part A, there is a part A, B, and C, so you should have 3 answers. The first part, A, is finding the value of the discriminant. Part B is telling the number of solutions that you have. So you either have 1 solution, 2 solutions, or no solutions, okay? And that the number of 1 solution is when the D equals 0, 2 solutions is when your D is positive, when your discriminant is positive, and when your discriminant is negative, you have no solution. So there's kind of a little key code for you. And then part C is doing the full-blown quadratic formula, okay? So there's kind of how that works. So A, B, and C on each part. So that's plenty of problems, but you should have enough time to work on that. The more you do it, the faster it goes. So maybe write down the quadratic formula at the top of this paper, and that will be helpful. Tomorrow I'll play that video for you of how you can remember that formula. Okay, so there it is, and that's all I have.